All right, hello. Come back again with me, Syafiq from INT. So today I am going to continue our lesson about uh partial fraction, but in another way. So we have a question and equation also. In this one, we have a limit of n approaching infinity and a 5 over n plus 2 is equal. So to solve this, we need to substitute the n again to make the equation is more simple. So all of that we need to uh, divide all the elements in the numerator and denominator with n. So the equation will be 5 over n over n plus 2 over n, and then it will change to 0 because 5 over n, limit n constantly is 5 over n is 0, and then the rest is calculated with the cell size n so it's supposed to be 0, and then 2 is what for n is supposed to be 1 plus n is equal to 1. So the result will be 0 over 1 plus 0, and then the result of the n is supposed to be 0, and it's converge. And for the next slide, we have a series set here. So the series is 1 plus 1 over 4 plus 1 over 9 plus 1 over 16 plus something, something, and something. It's equal to sigma is equal to sigma unity, and is equal to 1 over n squared. So as you can see, we need to solve this equation by finding its finding it says so the equivalence. So I think we just need to plug in first just one by one, just try it, and then just we have S1 is 1 over 1, which is 1. S2 is 1 over 1 plus 1 over 4, that's 5 over 4, and then we need to S3 is equal to 1 over 1 plus 1 over 4 plus 1 over 9 equals to 49 over 36. And then the rest of it is just 4 equals to 1 over 1 or plus 1 over 4 plus 1 over 9 plus 1 over 16 equals to 205 over 144. So next thing is we need to find the S5, you know. S5 is, yeah, just need to try it one by one. 1 over 1 plus 1 over 4 plus 1 over 9 plus 1 over 16, and then let's 1 over 25. So if we subtract it from or need to finish the equation, the answer will be equals to 5,269 over 3,600, and so on. Okay, I think that's for all of your question, and then let's move to the next question, which is need to find again the alpha differs. So in this equation, we have sigma infinity n is equal to 1, 4 over n times n plus 2 is equal to, yeah, that's it. This does it. Let me show how the best does it. And then we need to find if the value of this equation, we need to define if it's a converge or not. So first thing first, as you can see in here, we need to put the numerator outside the equation. So we the 4 is moving outside the equation, so it will be 4 sigma infinity of n equals to 1 1 over n square. So the you know the we need to multiple number with the in the brackets. So the this will be n squared plus 2 n, and then the rest is just you need to solve it, and then so it's limit n approaching infinity a n is equal to limit n approaching infinity 1 over n squared divided by n squared plus 2n over n squared. As you can see in here, we plug in the n squared because of the last theorem that in the number one that I saw you need to divide it on the equation by n. So in this case, we have a n square in here. So we just need to simplify it. So, so it's a n square that we use in this equation, and then okay, just need to start it all. So I set it again. Limit n square infinity 1 over n squared over n squared plus 2n over n square. So it will be 0 over 1 plus 4, 1 plus, sorry, so it will be 0 over 1 plus 0, so it will be 0. So 0 over 0. So we are 0 over 1, so it will be 0. And it's accomplished. Okay, I think that's it from me. Uh, Have a good day. See you in the next session. I hope you are understanding my mission today. Sorry if I have a mistake in nation, and maybe you can give me feedback or feedback for my teaching, such as step by step form, or maybe how do you get this, how do you get that, yada yada, and so on. So I think it's okay for now, and thank you and goodbye. See you in the next session.